Hi everyone, I'm Suresh Kumar, the working as assistant professor in Kunkunadu College of Engineering and Technology in Department of ECE. Today we are going to discuss about the subject is microwave and optical communications. So in specifically we are discussing about the unit number 2, the microwave measurements. So we are having the different types of measurements cover in this unit. So power measurement and VSWR measurement and impedance measurement like a frequency measurement. So these are all the different types of measurement we are going to discuss it in this unit. The first we see the topic is power measurements. So usually for measuring the power, we will calculate the voltage and the current, and by using the formulas, we will directly find out the power. In usually in the low frequency parameters, so we will find out only the voltage and the current. So from that voltage and current, by using the formulas, we can easily find out the power. But whereas in the high frequency ranges, so we cannot find out the voltage and current level in accurately. It is a very difficult task, so that we will use some kind of power measurement equipment. So from that equipment, we can easily find the power level of high frequency ranges. So in generally the microwave power is defined as the quantity of energy dissipated or stored per unit time. And the microwave power is divided into the three different categories. The one is called as a low power, and another one is a medium power, and the final one is a high power. The low power means the less than 10 milliwatts range of power, which is called as a low power, and the medium power means from the 10 milliwatts to 10 watts range is called as a medium power, and the third method is called as a high power. The high power means greater than 10 watts power ranges, which is called as a high power measurement. Okay, so in generally for the low power measurement, we are using the diode sensors, and the medium power measurements we are using the bolometer, and for the high power measurement we generally use a calorimetric method for find out the power levels. So for the already I said for the low frequencies we are using the diode sensors. So in generally most preferably we are using the Schottky diode. The Schottky diode, which is a zero bias Schottky barrier diode, is used as the square law detector whose output is proportional to the input power. Okay, so this is a general diagram of the Schottky barrier diode sensors. So when the RF input is applied in this circuit, so due to the temperature, the diode current will be varied. So from the diode current variations, we can easily find out the output temperature, easily find out the power level of the RF input. And the second method is called as a bolometer sensor. The bolometer sensor is used for the medium power sensing methods. So in bolometer, we are having the two different types of bolometer. The one is called as a barretter, and another one is called as a thermistor. A barretter is a thin wire that has a positive temperature coefficient resistance, and the thermistors are a semiconductor, so which a negative temperature coefficient divisions. So we know that what is a positive temperature coefficient, and we know that what is a negative temperature coefficients. Okay, so this is a circuit diagram for the bolometer sensors. So here we are having the balanced bridge. The balanced bridge here, this portion which is called as a bolometer sensor. So when we are applying the microwave power, at initially the bolometer sensors, so which is having the reading in zero. Zero means so the when the bridge is balanced conditions, the it will show the reading as zero in the meter. So when we are applying the microwave power in this bolometer, the bridge going to the unbalanced conditions. It's correct or not? The bridge is going to the unbalanced conditions. Due to the unbalanced bridges, the galvanometer will show the some kind of reading. So from that reading, we can easily find out the power levels. Okay. So this is a one kind of medium power measurement. So here we are having the some drawback in this circuit. Suppose even though in the room temperature is also this bolometer will sensing it, so that we can segregate the room temperature and also the microwave power. So for that purpose, we are using this double bridge method. So in this double bridge method, the one bridge which is used to identify the actual RF input power, and the another one bridge which is used to identify the ambient temperature. These two power levels will be giving to this amplifier, differential amplifier. The differential amplifier will differentiate the ambient temperature from the actual RF input temperatures. So that we can easily find out the accurate power level from this method. Thank you.